Let's now talk about one of the most important concepts in Python, which is recursion. Let's see recursion in action. What exactly is recursion? Recursion occurs when a function calls itself. So a function calling itself to solve a problem is recursion. Now you might think, why would a function call itself and why would we do this? To understand this, let's create a file called 04_recursion.py and let's create a function. Let us say I want you to print out the Fibonacci sequence. Now, what is a Fibonacci sequence? Let me show it to you. The Fibonacci sequence, Fibonacci series, it's a series which starts with 0 and then we keep on adding the first two default numbers and obtain the third, fourth, fifth, sixth and so on numbers. So the first value is 0, the second value is 1. Let me show it to you. So the first value is 0 and the second value is 1 and the third value is obtained by adding these two values. So the third value is 0 plus 1, which is 1. The fourth value is obtained by adding previous two values. What are the previous two values? 1 and 1. Now, next value is the sum of previous two values. So we'll put a 3 here. Again, the next value is the sum of these two values. So we'll put a 5 here. So 0, 1, 1, 2, 3, 5, 8, 13. And any value in Fibonacci series is derived by summing previous two values. So by default, fib0, let's say we have a function to write Fibonacci series. So fib0 is equal to 0. And then we have fib1, which is equal to 1. And then rest of the values are derived by summing previous two values. What is the value of fib2? I can do something like fib0 plus fib1 plus fib1. Okay. And we can derive as many values as possible. Let me write a multi-line comment here to write this even better. Okay. So let's close this multi-line comment here. So this is how Fibonacci series work. This is the Fibonacci series and then fib0 is 0, fib1 is 1 and then fib2 is fib0 plus fib1 and then we can keep on going like this and we can have other values as well. So I can say fib3, fib4 and then I can say fib3 is fib2 plus fib1, fib1 plus fib2, fib1 plus fib2. And then this will be fib2 plus fib3, basically the previous two values. Okay. Now, what will be fibn? I know we are going a bit mathematical here, but let me show this to you really well. And I want you to understand it really well. And we'll have to go mathematical. Fibn will be fibn minus 2, which will be previous to previous value, plus fibn minus 1. Yeah, this is a mathematical problem and you'll have to understand it. So basically this is last to last number. This is a last number. Okay. So for 13, fibn minus 1 is going to be 8 and fibn minus 2 is going to be 5. And we added these two numbers to get 13 in the Fibonacci series. Okay. Awesome. So we understood it. So this is the formula that we derived. Fibn is equal to fibn minus 2 plus fibn minus 1. Now let's write this fib function. We want to write this function and we want to get the value of fibn for a given value of n. So let's say the value of n is 0. I want 0. Let's say the value of n is 1. I want to get 1. And 0, 1, 2, 3, 4 are indices. So these are indices 4, 5, 6 and so on. And index in Python starts with a 0. We all know that. Okay. We don't start counting from 1. We start it from 0. Awesome. So let's write this fib function, or at least let's give our best to write this fib function. Can we do something like return fib n minus 2 plus n minus 1? Will this work? This is the formula, right? And it should be straightforward. Will this work? Let's see what happens if we put n is equal to 0 in the formula. For n is equal to 0, this becomes fib minus 2 plus fib minus 1. But Fibonacci series is not defined for negative numbers. And in fact, we don't have negative indices. We do, but again, for this sequence, it doesn't make any sense. What about n is equal to 1? If we put n is equal to 1 here, it will be fib minus 1 plus fib 0. Do we want that? Do we really want that? No, we don't. We don't want that. So fib minus 1 plus fib 0 doesn't make any sense. So for n is equal to 0 and n is equal to 1, this formula is not holding true. But for the rest of the values, this formula will hold true. So we'll have to manually define what happens for n is equal to 0 and n is equal to 1. This is called base case of recursion. So let me write down base case of recursion. Base case of recursion. So we say if n equals to 0 or n equals to, and I'm putting a double equals to because that's the equal to in Python. So if n is equal to 0 or n equals to 1, what you do is you return n. Okay, so if n is 0, you return 0. If n is 1, you return 1. That is how the first two values are defined. And for rest of the values, we simply compute it using the formula. Now let me show you how this exactly works. Let's see if this is even working or not. Let's print fib5 0. Fib5 should be fib5 should be 5 actually. Let's see if this is the case. Yes, it's working. Fib5 is 5. Let's see if fib6 is being printed properly. If we do fib6, it's showing us 8. Yes, fib6 is 8. And it's simply working well. But let's understand even more precisely how this works. So whenever I write fib6, the value of fib6 is passed here. The n is equal to 6 is passed here. And this particular if statement is false because n is neither 0 nor 1, it's 6. So for n is equal to 6, this becomes fib4 and fib5. So the problem is now broken down to fib4 plus fib5. Fib4 plus fib5. But what is fib4 and fib5? Fib4 is further broken down and n is equal to 4 is passed to the function. The function calls itself. N is equal to 4 is passed to the function and fib4 is broken down to fib2 plus fib3 and then fib5 will be written as is. This will be resolved later. Now what is fib2? N is equal to 2 is passed. This base case is not true. So it will be fib0 plus fib1. So it will be fib0 plus fib1. And then this will be written as is. Awesome. We understood so far. Now we actually have a value for fib0 because whenever we pass n is equal to 0, we get it returned. So if n equals to 0 or n equals to 1, we are returning n. So in this case, fib0 will be 0 and fib1 will be 1. And fib3 is broken down to fib1 plus fib2. And this is how it works. And then further fib5 is broken down into fib3 plus fib4. So let's break it down to fib3 plus fib4 plus fib4. And this keeps on resolving and we will finally get the value. So let's keep on resolving this. 0 plus 1 plus fib1 is 1. Fib2 will be fib0 plus fib0 plus fib1. We are basically resolving it manually. And then fib3 will be fib1 plus fib2. And then let's write this fib4 as is. And then once again we have 0 plus 1 plus 1. And then we'll have the values of fib0, fib1 and fib1 resolved, which will be 0 plus 1 plus 1 plus 1. And then we have fib2 again, and fib2 is nothing but fib0 plus fib1 once again. And fib4 is nothing but fib2 plus fib3. Okay, so let's write fib2 plus fib3 and this keeps on resolving, and let's keep on resolving this. Let me copy this line. This will be 0, this will be 1 and this will be fib0 plus fib1. Okay, so let's write it down. Let's replace fib2 with fib0 plus fib1. And then once again, let's replace these values. Fib0 will again be 0, fib1 will again be 1, and fib3 will be fib2 plus fib1. Fib1 plus fib2, we can write in this order. And fib1 will be 1 and fib2 will be fib0 plus fib1. Fib0 plus fib1. And then again, let's replace this with 0 and 1. So this will be 0 and this will be 1. Let's see what it translates to and we'll see the value. So let's calculate it using Google, and it's 8. And let's see if fib6 is 8. And yes, fib6 is 8. Now we actually calculated this manually the hard way. Okay. And I hope that you understood it, how we broke down these functions and understood how these values are getting replaced by Python. This actually is calculated in a matter of milliseconds using Python, which is great and exciting. And whenever we provide a larger number to Python, it will do even better job. Now, why do we use recursion? Because it is sometimes the direct way to solve a problem. Should we even use recursion? The answer is yes, we should. We should definitely use recursions. But why should we use recursions? Because it is directly solving this problem. In this case, it is solving for the Fibonacci series. We have the value, we have the formula, we have the base cases, and we just wrote few lines of code and a function is ready. We cannot define these base cases using iterative methods this easily. We can definitely do that. We can use loops, but not this easily. This is really straightforward. And whenever we have a formula of a function in the form of itself, we use recursions because they are one of the best ways and direct ways of solving the problem sometime. I hope that you understood recursion, and if not, please watch this video again. Please watch this video again, it will be fun. And I have taken a bigger example of fib6 because I really wanted to explain how these values are getting replaced by even broken down values and then the base cases. Do have a look and do solve this problem yourself. If you are not able to evaluate fib6 properly, I will insist that please do not leave this topic. This is very important topic and I want all of you to solve for fib6 using a copy and a pen. Go ahead and break this function down and start writing on a piece of paper. Write fib6, break it down to fib4 and fib5, then further break down fib4, then further break down fib5, and keep on going, and you'll see how recursions are working behind the hood in Python. Awesome. So I've written everything down in the handbook and I hope it is useful. Let's look at two important points. First is must have base case to avoid infinite recursion. So if you mess up writing this code, what happens is this keeps on breaking down. For example, if you don't have this base case, this will keep on running for negative values and it will keep going until you crash your program. Your memory will be full and your program will be crashed and you'll get a runtime error, and you don't want to mess up the conditions. You don't want to write bad code. So whenever you're writing recursion, one thing that can be a downside of recursion is that you have to be very, very careful. You don't want to mess up while writing recursive programs. And this is something that gets difficult with complex programs. If you mess up, you are going to fill your stack, you are going to fill your memory, and everything will go unplanned. We don't want that. And second is that it's used in algorithms like Fibonacci and tree traversals, which you will study in data structures and algorithms sometimes later. So yeah, that's how we use recursion, and I hope you understood and enjoyed as well. See you in the next video.